Hello, good morning to all of you and Happy New Year. That is 2023, in which you all have to give the examination. I am your teacher here, Ravi sir, who has experience of 30 years teaching in different institutions, and now I have launched my own study center, that is Target International Study Center. With this name you can search my videos in which you can prepare in very small time. In class 10th, we have to study 4 chapters in chemistry, and these 4 chapters are included in my presentation. तो सबसे पहला चीज, आप लोगों को नया साल मुबारक हो, मेहनत कीजिए, पढ़ाई करते रहिए. Let us start our discussion with my own topic and with a very good note which is given in Bhagavad Gita. कर्मण्येवाधिकारस्ते मा फलेषु कदाचन मा कर्म फल हेतुर्भु माते संगो सत्व कर्मणि. तेरा कर्म करने में ही अधिकार है, उसके फल में नहीं. गीता का सार है ये. यानी आपको मेहनत करनी है, फल देना ईश्वर का काम है. फ्रॉम हियर वी कैन स्टार्ट द डिस्कशन ऑन केमिस्ट्री फॉर क्लास 10 according to CBSE in 1 hour. Now let us go to the chapters one by one. You all know, starting from the first chapter, what are the different topics? The chapter is chemical reactions and equations, which is divided into 4 topics. First chemical reaction, then chemical equation, types of chemical reactions, and effect of redox reaction in everyday life. सवाल उठता है कि इन टॉपिक्स को थोड़े में कैसे समाप्त किया जाए. Now let us begin the journey, starting you here with the journey of chemical reactions. Reactant on left side, product on right side, separated by arrow. मतलब रिएक्टेंट बाईं तरफ, प्रोडक्ट दाईं तरफ, बीच में एक एरो का निशान जिसके ऊपर या नीचे कंडीशंस लिखे जाते हैं. ये पूरा का पूरा फॉर्मेट कहलाता है केमिकल रिएक्शंस. अब सवाल उठता है हाउ टू आइडेंटिफाई, यहां रिएक्शन हो रहा है या नहीं. दैट इज कॉल्ड कैरेक्टरिस्टिक. वन क्वेश्चन में बी आस्क्ड फ्रॉम दिस. पहला कैरेक्टर है चेंज इन स्टेट. यहां अमोनिया एंड हाइड्रोक्लोरिक एसिड बोथ आर इन गैसियस स्टेट which will convert into ammonium chloride which is in liquid state. क्वेश्चन आ सकता है. नेक्स्ट इज चेंज इन कलर. यू ऑल हैव टू फोकस ऑन कलर्स, क्योंकि होता क्या है कि डिफरेंट कलर चेंजेस आर आस्क्ड इन योर क्वेश्चंस. यहां आपके पास सिल्वर है जिसका सिल्वरी व्हाइट कलर है, रिएक्टिंग विथ H2S गैस टू प्रोड्यूस Ag2S. Ag2S मींस सिल्वर सल्फाइड which is black in color with the release of hydrogen gas. The third character is evolution of gas. Zinc or any other metal like this which is placed above the hydrogen in activity series, reacting with acids, they will release hydrogen gas. अब आते हैं हाइड्रोजन गैस. हाउ टू बी टेस्टेड? विद द पफ साउंड बाय बर्निंग स्फिंक्टर नियर इट. मतलब एक माचिस की तीली जलाकर अगर हम उस हाइड्रोजन गैस इवोल्यूशन के पास ले जाते हैं तो इट विल प्रोड्यूस पफ साउंड एंड एक्सटिंग्विशेस. सो दिस इज द कंडीशन टू टेस्ट हाइड्रोजन गैस. इसके बाद आते हैं चेंज इन टेम्परेचर. हाउ चेंज इज हैपनिंग? आइदर इट इज गोइंग टू टेक हीट और इवॉल्व हीट. बोथ कंडीशंस आर कनेक्टेड विथ चेंज इन टेम्परेचर. दैट मीन्स आफ्टर द रिएक्शन आइदर the product is hotter or colder. If it is hotter, the reaction is exothermic. If it is colder, reaction is endothermic. Now The last one is formation of precipitate. Now what is precipitate? Precipitate, anything that settles down after the reaction. Small particles that settles down undissolved in water or aqueous solutions, water solutions, is called precipitate. Here barium chloride reacting with sulfuric acid produces barium sulfate, which is white in color, precipitate with hydrochloric acid. So now how to balance? Actually there will be no question from hit and trial method, but you all have to write the equations that must be in balanced form. मतलब आपको सारा का सारा इक्वेशंस बैलेंस्ड फॉर्म में लिखना होगा, क्योंकि केमिस्ट्री इज अनेबल टू थिंक अबाउट विदाउट द इक्वेशंस और रिएक्शंस. तो सबसे पहले क्या करना है, फर्स्ट स्टेप, ड्रॉ बॉक्सेज और ब्रैकेट्स अराउंड ईच फॉर्मूला. फॉर्मूला को एलिमेंट वाइज डिवाइड करके उसके सामने नंबर ऑफ एटम्स को लिख देना है ऑन बोथ साइड, आइदर ऑन रिएक्टेंट और प्रोडक्ट, कीपिंग वन कंपाउंड इन वन बॉक्स. आफ्टर दैट स्टार्ट बैलेंसिंग. कैसे? विथ एटम्स मैक्सिमम नंबर एंड नेगेटिव रेडिकल. मतलब स्टार्टिंग फ्रॉम ऑक्सीजन, followed by halogens like fluorine, chlorine, bromine if present, then followed by sulfur dioxide or sulfates, nitrates, carbonates, and so on. We will move to hydroxide. पहले उनको बैलेंस करें, फिर उनके साथ कनेक्टेड पॉजिटिव रेडिकल यानी मेटल्स को बैलेंस करेंगे. And in this way you are going to get a very easy way to balance a chemical equation. And after the balancing, write the integers of a skeletal equation before the formula. फॉर्मूला के पहले उस इक्वेशन के नंबर को लिख देना है. नाउ इट इज ए बैलेंस्ड केमिकल इक्वेशन. नाउ मूव टू द नेक्स्ट टॉपिक, टाइप्स ऑफ केमिकल रिएक्शन. कौन कौन सा रिएक्शन पढ़ना है? कॉम्बिनेशन रिएक्शन, डिकम्पोजिशन रिएक्शन, डिस्प्लेसमेंट रिएक्शन, डबल डिस्प्लेसमेंट रिएक्शन एंड रेडॉक्स. ये 5 रिएक्शंस आपने पढ़ने हैं. कॉम्बिनेशन में क्या होता है कि व्हेन देयर आर 2 और मोर रिएक्टेंट्स टू गिव ओनली वन प्रोडक्ट, सिर्फ एक प्रोडक्ट, कहलाता है कॉम्बिनेशन. सेकेंड, डिकम्पोजिशन, एक रिएक्टेंट मोर देन वन प्रोडक्ट, डिकम्पोजिशन. डिस्प्लेसमेंट, हाईली रिएक्टिव मेटल विल डिस्प्लेस low reactive metal from its salt. Here you can see AB plus C. Here A is positive radical, B is negative radical, and C is also positive radical. So C will take away B from A and get A alone. So this Cb plus A as product is result of displacement reaction. That means C had displaced B from A. Now in double displacement reaction, exchange is there. AB plus CD, A will take the D and C will take the B. That means AD plus CB will be the result of double displacement reaction. And redox, oxidation and reduction. The simple definition of redox is when we add oxygen or remove hydrogen, it is called oxidation. When we add hydrogen, remove oxygen, it is called reduction. Now combination reactions in detail. There are 2 different result of combinations. First of all, we will call exothermic and endothermic. Exothermic, 90% of the combination reactions are exothermic because in them the heat is evolved. With one product the heat is produced, that is called exothermic combination reaction. They all can also called as redox because all reactions are redox reactions. Now here we have taken the example of carbon with oxygen that produces carbon dioxide with heat. Again H2 plus Cl2 will give 2HCl with heat. Similarly sodium with chlorine to give sodium chloride and heat. Iron with sulfate give iron sulfide with heat. Calcium oxide with water, calcium hydroxide with heat. Everywhere you will see in the exothermic reaction the heat is evolved and the product is if only one, then it is called combination reaction. Now if the heat is absorbed, that means if more than one reactants are involved, after heating they will produce only one product, then we will call them as endothermic reactions. It can be actually decomposition reaction or combination reaction. So here is one example of nitrogen and oxygen. When heated together they will give nitrogen oxides with absorption of heat. Now in the case of decomposition reaction, here is only one reactant giving us two products or more than two products. So there are three conditions. First, thermal decomposition, that means use of heat. When we are going to heat any of the compound which is present as reactant, it will produce two or more products. मतलब heat की जरूरत है. अब आते हैं यहाँ, it is very important. All the three equations given in this slide of thermal decomposition are very important. First of all, calcium carbonate, which is limestone, when heated it produces calcium oxide with carbon dioxide. This calcium oxide is going to dissolve in water to produce calcium hydroxide, and this calcium hydroxide is used to whitewash our wall, which absorbs carbon dioxide from air to produce calcium carbonate that makes the color of our wall white. Similarly, ferrous sulfate, when heated, it is going to produce iron oxide, which is brown in color with the smell of sulfur, having both its gases, sulfur dioxide and sulfur trioxide. Similarly, lead nitrate, when heated, it gives lead oxide with nitrogen dioxide and oxygen. That is actually brown fumes. So the first part of thermal decomposition is very important. The next is electrolytic decomposition, in which with the help of electricity, water breaks into hydrogen and oxygen. Hydrogen is released at cathode, oxygen is released at anode. Now move to the next, photolytic decomposition. Photolytic means use of sunlight. Whenever we are going to use sunlight against the compound silver bromide or silver chloride, automatically it will break into silver and chlorine or bromine. The result, it is used in the case of photography. Whenever we click the photograph from a camera, what happens? The sunlight enters through the camera and hit the plate paper of silver chloride, in which silver is going to break down and chlorine is released. Thus the image will be there. Similarly, other decomposition reaction, you can take potassium chlorate KClO3, which breaks down in the presence of manganese oxide MnO2 to give 2 KCl and O2. Similarly, sodium chloride breaks into sodium and chlorine. Hydrogen peroxide breaks into water and oxygen. Now move to the next, that is our displacement reaction. Here what happens? The high reactive metal is going to displace the low reactive metal from its salt. Equation is just like that. Iron is more reactive than copper. So iron is going to displace sulfate from copper sulfate, which is blue in color, and convert it into green, that is iron sulfate releasing copper alone. So this condition is called displacement reaction. So color change you have to remember. Evolution of hydrogen gas is also there in the case of Mg plus H2SO4. Similarly, copper chloride when reacts with lead which is more reactive than copper, takes away chlorine, which is given green color to copper chloride, to colorless plumbous chloride, releasing copper. Another reaction, that is thermit reaction, in which actually we are going to heat iron oxide with aluminium, used for filling the cracks of bridges. Basically the iron machines, if they have cracks, we can cure it with thermit reaction, because a large amount of heat is released along with the formation of aluminium oxide and molten iron, and this molten iron is going to fill the space. Now move to the next part, that is double displacement reaction. क्या होता है इसमें? AB plus CD convert AD plus CB. जैसे सोडियम नाइट्रेट, सिल्वर नाइट्रेट एंड सोडियम क्लोराइड, तो क्या होगा? सिल्वर विल टेक क्लोरीन AgCl, white precipitate, and sodium will go with nitrate NaNO3. Similarly, lead nitrate and sodium chloride, sodium will take nitrate and lead will get the chlorine. in the form of white PPT. So this type of reactions in which exchange of ions takes place is called as double displacement reaction. अब सवाल उठता है व्हाट इज द इम्पोर्टेंट, कौन सा इंपॉर्टेंट है? तो यू मस्ट हैव टू गो विथ द लास्ट वन, that is potassium iodide reacting with lead nitrate. It will give us yellow precipitate PbI2 along with 2KNO3. You must have to go with this reaction so that you can easily get it, and this reaction may come in your examination, so focus on it. In the 23 CBSE board exam, you have to keep in mind this one very clearly. Now move to the next part, that is redox. अब सवाल उठता है कैसे पहचानेंगे रिडक्शन और ऑक्सीडेशन को? इसमें आपको ध्यान रखना होगा, you have to fix on the valencies. सबसे पहले we have taken MnO2. You can see here MnO2. ऑक्सीजन का वैलेंसी होता है -2. When 2 atoms of oxygen are involved, you will get -4. To balance this -4, you have to use this +4 to make it 0. Now you can see in the case of chlorine it is -1, and here hydrogen is +1. Now what happened here? Now you can see here Mn from 4 has converted into Mn2. First do this. You can see here it had changed from +4 to +2. That means when decrease is there, it is called reduction, which I am going to show with red. Red means reduction here. And on the other hand, chlorine is going to change from -1 to 0. What you see? -1 to 0, that means increase. Increase is oxidation. The question will be asked from this part. You have to find out which compound is oxidized and which compound is reduced. That means you have to find out the oxidation and reduction part or oxidant and reductant part. So what is reduced? MnO2. This particular compound is called as oxidant. This particular compound is called as, that is MnO2 is oxidant. And on the other hand, the left behind, that is HCl, is called as reductant. You have to go like this. This particular is called reductant. So now you all know about redox reaction. कैसे करना है? सबसे पहले get their valencies. If there is increase, it is oxidation. If there is decrease, it is reduction. जो reduce हो रहा है वो oxidant है, जो oxidize हो रहा है वो reductant. So now we will move to the next part of this slide. Effect of redox reaction in everyday life. This is one of the important. क्या effect पड़ता है? पहला है रेस्पिरेशन, डेली लाइफ में यूज होता है, जिसमें ग्लूकोज को ऑक्सीजन के प्रेजेंस में जलाया जाता है, 38 ATP एनर्जी का प्रोडक्शन होता है विथ कार्बन डाइऑक्साइड एंड वाटर. यू हैव टू स्टडी दिस रिएक्शन आल्सो इन बायोलॉजी सेक्शन, so you must remember it. Then the case of combustion is there. Carbon reacts with oxygen to produce carbon dioxide and heat. So now we will move to the next part, that is called corrosion, which is also one of the important topic. In corrosion, the question will be asked, give the formula of rust. So you have to write or choose the correct option from here. Fe2O3.xH2O. Focus your brain here. Fe2O3.xH2O is the formula for rust. How it happens? Iron is going to rust in moist air, in which oxygen is going to combine with iron to produce iron oxide with X water of crystallization in water. Remember, the number is not fixed depending on the moisture. In second case, copper is going to convert into basic copper carbonate, which is green in color. Here the reaction takes place between carbon dioxide and water. मतलब moist carbon dioxide is going to react here with copper to turn it green, and on the other hand silver, it reacts with H2S which turns it into black. That means the destruction of the metal goes on and the color changes there, and the phenomena is called as corrosion. Now move to the next part, that is rancidity. What is rancidity? It is actually the slow oxidation of oil and fat present in food, resulting in foul smelling compounds, bad smelling compound. मतलब ये गंदा गंध, जब आप खाना कुछ दिन के लिए रख देते हैं, what happens? Obviously उसमें से स्मेल आना शुरू हो जाता है. You are unable to take it now. So this type of conditions are called as rans, and the phenomena is called as rancidity. Now how to prevent rusting? Rusting बचाएं कैसे? First of all, coating with paints like biphenol. Remember this, what the name of compound, that is biphenol, which is used in paints to protect it from rusting. When you are going to protect iron from rusting, you have to use the phenol paints that contain biphenol. Even after that, the application of thin film of oil and grease ऊपर से लगाया जा सकता है. Electroplating. Now there is difference in two words, electroplating and galvanization. Electroplating with tin, nickel, chromium and aluminium. All these four metals can be used for electroplating. Even aluminium is known as anodizing, that we will learn later. But in galvanization you have to fix yourself, that is with zinc. You can see here, this is our zinc. Sacrificial protection, मतलब अपने आप को समाप्त करके बचाना. This is sacrificial protection which is done with the help of zinc. When zinc is coated over anything else, so how it is done? Electroplating, that means use of electrolysis. The zinc will be used as anode, and whatever metal we are going to cover is used as cathode. Remember it. Or use of anti-rust solution, which we have a large number of anti-rust solutions made that can prevent rusting. The same condition, methods to protect from rancidity. कैसे बचाएंगे with rancidity? So actually the packing in air, tight container, flushing of inert gas in packets. You have seen the potato chips. Chips के पैकेट में हवा भरी रहती है. What is that gas? That is nitrogen. Nitrogen इसलिए भरा जाता है, it is less reactive and protect it from being destroyed or producing foul smell. So everywhere it is advised not to take the packet that doesn't contain air in it. Other method is refrigeration or putting food away from sunlight. Both are going to protect from rancidity. Now the first chapter you have completed. Move to the next one. The second chapter is of acids, bases and salt. It is connected with metals and non-metals also, because whatever we study in acids, bases and salt, they will continue with metal and non-metal. Now here what happens? Acids, bases, neutralization reaction. The first topic, identification of indicators. Indicators क्या हैं? जो पहचानते हैं, कलर चेंज के साथ बताते हैं, this is an acid, this is a base and so on. अब सवाल उठता है, how to get the strength of acids and bases? स्ट्रेंथ कहां से मिलेगा? पावर कैसे पता लगेगा? That is potential, pH. pH value will decide. If there is 0 pH, it is powerful acid. If it is 14 pH, it is powerful base. 7 is the neutral solutions. We will discuss it in detail. Salt, different salts we have to study, how to produce, what are the uses and so on. Again the question will be asked from water of crystallization. Why this water of crystallization is present and what is water of crystallization? That we have to discuss one by one. Now move to the topic, acids and bases. It is connected with Arrhenius concept, what we have to study on. Arrhenius concept tells us if the number of hydrogen ion is more compared with hydroxide ion, that means this aqueous solution is acidic. Gases never behave as acids. If HCl is in gaseous state, it will not turn blue litmus red. Remember, gaseous stage में कभी भी कोई एसिड अपना बिहेवियर नहीं दिखाता है. They need an aqueous solution. So here in Arrhenius concept, if the number of hydrogen ions are more compared with hydroxide ion, you will get it. The first example is HCl plus H2O. You can see here there are two hydrogen ions here. The first one is here and the second one is here. And you can see here if two hydrogen ion, which is always greater than hydroxide ion, so it is an acid. Similarly, if the hydroxide ion are more, it is the base. So remember it. दूसरा तरीका पहचानने का, हाइड्रोजन मस्ट बी प्लेस्ड इन द बिगिनिंग ऑफ द कंपाउंड. HCl, HNO3, H2SO4, H2CO3, H3PO4, HNO2, H2SO3 all contain H at the beginning. मतलब क्या हुआ? They are acids. Similarly, if it ends with COOH, you can see here COOH is there. If this COOH is there at the end, not OH, here is you can see OH without CO. So containing compound that has only OH in it is a base. Remember, if COOH is there, it is an acid. OH is base. Now move to the next part to identify them. What are the chemical properties? सबसे पहले हम लोग को chemical properties समझना है, compare करना है. Acids and base, all bases are not going to react with metals because they are basic oxides, except three. कौन कौन सा तीन? Zinc, aluminum and lead. Zinc is going to make zincate, aluminum is going to make aluminate, but all of them will react with two base only, sodium hydroxide, potassium hydroxide. But in the case of acids, whatever metals are placed above hydrogen in the activity series, they will automatically produce the salt with hydrogen gas, which you can test with puff sound. Now if it is going to react with metal carbonates, here it is mentioned metal carbonates, Na2CO3, or metal sulfates, metal nitrates, whatever be the metal salt, when they are going to react with acids of some another variety, the release is there of whatever salt will convert into gas. Carbonate will convert into carbon dioxide, sulfate will convert into sulfur dioxide, nitrate will convert into nitrogen dioxide. Remember it. Metal carbonates, carbon dioxide, metal hydrogen carbonates, carbon dioxide, as is mentioned here. But in the case of bases, they will not show any reaction with metal carbonates or metal hydrogen carbonates. Question will be asked why? You can answer. Metals form basic oxides, so they don't react with bases. Answer is yours. Now metal oxides when react with acids, the extension of the first part, they will form reactivity salt and water. But in this case, metal oxides, as they are basic, they are not going to react with base. But if the non-metal oxide is the case, so non-metal oxides are acidic in nature. Like carbon dioxide gives carbonic acid, nitrogen dioxide gives nitrous acid, nitrogen trioxide gives nitric acid, and so on. So they will not show any reaction with acids, but non-metal oxides will show reaction with base. Like calcium hydroxide reacts with carbon dioxide to produce calcium carbonate and water. Now move to the next part, that is indicators. What is indicator? What are indicators? Indicators are actually that changes their color in the presence of acid or base. Here are few examples. Litmus, blue turns into red in acid. In base, red turns into blue. Red cabbage leaf extract, red in color. Acid, no change. In base, it turns into green. Hydrangea, blue to pink. Turmeric, no change. In base, yellow. Phenolphthalein, colorless in acid. Pink in base. Methyl orange, red in acid. Yellow in base. Remember, this one is more important. That is methyl orange, hydrangea, and turmeric. You have to remember these three minimum so that you can answer the questions connected with indicators. Now move to the next part, that is a strength. How to define a strength? A strength of an acid is based on pH scale. It is checked by universal indicators. Universal indicators turn from violet to red. You have heard about Vibgyor, the rainbow colors: violet, indigo, blue, green, yellow, orange, purple. So this particular color change, starting from 14 reaching to 1. You can see here violet is 14, 13, violet 12, 11, 10, purple, navy blue 8, greenish blue. Ultimately the neutral solutions are green. Remember, violet center में green, last में red. That is 1, 2 red, 4 orange, 5 between them. So this is actually the strength of acid base. Don't remember, just memorize Vebgyor starting from 14 to 1. Here I have given some pH values which may be asked, because 90% of the cases we have to deal with these conditions. Saliva before meal is basic compared with saliva after meal. Remember this type of questions can be asked. What happens to the pH if we take food of the saliva? So you can see here saliva before meal is 6.5 to 6.9, that is very near to neutral. But saliva after meal it will 5.1 to 5.5 because of growth of bacteria which is present or produced after taking food inside our mouth cavity. Similarly, lemon juice is acidic, containing citric acid. Aerated drink contains carbonic acid, and so on. Now move to the next part, importance of pH in everyday life. Here few questions can be asked. The basic question regarding soil: how the acidity of the soil can be removed? Addition of quicklime or select lime. Remember the formula for quicklime CaO and select lime CaOH whole 2. You can get the answer. One question may be asked from milk of magnesia, how it is produced and how it can neutralize the acidity in the stomach. You can answer the question. Milk of magnesia is produced by burning magnesium ribbon, because magnesium is also a protective layer of magnesium oxide over it. So you have to rub it properly before burning. When you burn, it will produce white powder, that is magnesium oxide, and this white powder is dissolved in water to produce magnesium hydroxide, which are used as antacid to neutralize acidity in our stomachs. Similarly, how to preserve milk for longer time? Addition of sodium hydrogen carbonate, because pH value of milk is 6, which is slightly acidic. Now you have to make it basic so that lactobacillus bacteria does not grow in it, because presence of lactobacillus bacteria is going to destroy the milk. Similarly, tooth decay, pH value of mouth is less than 5.5. Enamel, which is made up of calcium phosphate, remember calcium phosphate, not calcium carbonate, which is the hardest substance in our living beings, to protect teeth from neutralization, which is done by basic toothpaste. Remember what? Calcium phosphate is going to cover up as enamel. Now different salts, how to produce them, how different salts are produced. So first of all, the source of our all salt is ocean. You all know ocean water is salty, which we call as brine. Salt with water is called brine. How it is produced? The first compound that we are going to get from here is sodium hydroxide. कैसे? हम लोग बनाते कैसे हैं इसको? By chlor-alkali process. What we have to take? We have to take molten sodium chloride or brine in the presence of few drops of NaOH solution, so that NaOH will start the reaction, initiate the electrolysis. Hydrogen will be released at graphite cathode and chlorine gas will be released at graphite anode, and the NaOH is present as aqueous solution there. The production of NaOH is there. Now after this chlor-alkali process, whatever chlorine is released, it is used to produce bleaching powder. From where it is? The second salt, calcium oxychloride, that is called bleaching powder. Remember, question can be asked: calcium oxychloride, chemical formula, name of the bleaching powder, and so on. How it is produced? calcium oxide, which you all know. After heating calcium carbonate, it breaks down into calcium oxide and carbon dioxide. Now this calcium oxide is put in water, which is quicklime, produces slack-lime, calcium hydroxide. Now when we pass chlorine gas from calcium hydroxide, it will automatically convert into calcium oxychloride. That is our bleaching powder. Now goes to baking soda, which is also known as sodium hydrogen carbonate. How? ब्राइन ले लेना है, अमोनिया गैस, कार्बन डाइऑक्साइड गैस पास कर देना. सिंपल. ब्राइन सॉल्यूशन, सोडियम क्लोराइड और वाटर का सॉल्यूशन, उससे अमोनिया गैस और कार्बन डाइऑक्साइड पास करना है. यू विल गेट अमोनियम क्लोराइड विथ सोडियम हाइड्रोजन कार्बोनेट, which can be filtered out. Now question will be asked here, when we bake a cake with baking soda, it will taste bitter. क्यों? Because baking soda is actually basic in nature, and when we use it to bake a cake, that means heat it, you will get the third salt, that is washing soda. Sodium hydrogen carbonate will convert into sodium carbonate, and that will taste bitter. To neutralize it, you have to add tartaric acid or some edible acid, and the mixture of baking soda with tartaric acid is called baking powder, the third salt. Now move to the next part, sodium carbonate or washing soda, which is used to prepare the detergents. It actually contains 10 water of crystallization. When it is in crystal form, it contains 10 H2O. Now move to the next part, that is plaster of Paris, which is used by doctors to repair our bones when they are fractured. What is the name of the compound? Plaster of Paris. Calcium sulfate hemihydrate. What this means? It is a compound of calcium sulfate with half water molecule. Similarly, it is obtained from gypsum, which has 2 water of crystallization, calcium sulfate bihydrate. When we heat it at 373 Kelvin or 100 degrees Celsius, we will automatically get plaster of Paris in powder form, which can be used by our doctors. Gypsum to plaster of Paris. Now here I have given some important water of crystallization with the name of the compound. Gypsum, CaSO4 0.2 H2O, 2 water of crystallization. Plaster of Paris, CaSO4 0.5 H2O. Blue vitriol, CuSO4 pentahydrate, 5 H2O. Iron sulfate, FeSO4 0.7 H2O, that is 7 water of crystallization. Sodium carbonate decahydrate, Na2CO3 0.10 H2O. What actually water of crystallization means? The water that convert any salt into crystal is called water of crystallization. It is hidden inside the crystal. When you heat, the crystal will lose its color and become white. Remember, question can be asked, if any compound containing water of crystallization in it has different color, after heating it will lose water of crystallization and convert into white powder. You can answer the questions now. Now if you need study material for class 10th session 22-23, WhatsApp me at 82108-70439 or 90977638809. This is my WhatsApp number at which you can get whatever study materials in short you need. And if you have any queries or any questions, you can write in my comment box also. So this is the way how you can connect with me, and if you have any problem, you can easily get it. And if you have need this video or study materials, please like and subscribe my channel, so that if I will upload the physics 1 and biology section of the same series, you will get the notification very easily. If you like, the question is there, then only you have to do it. Now move to the next part, that is the third chapter, which is metals and nonmetals. Now the topic, what is that? Properties. You have to study about metals and nonmetals. Physical properties, chemical properties. Physical properties very easily to understand, mostly solid. possess high density, high melting boiling point, lustrous, sonorous, malleable, ductile and good conductor. That are metals. नहीं पता. Lustrous चमक यानी shining, sonorous आवाज ध्वनि, malleable bitten into sheets, पतला शीट चादर बनाने वाला, ductile drawn into wires, thin wires में बदलना, conductor you all know, transferring heat or electricity throughout the conductor. You have to remember here soft metals like sodium, potassium and lithium. They can be cut by knife. Liquid metal is mercury and liquid non-metal is bromine. Remember. Densest metal, the question can be asked, osmium. Metal melts on palm, cesium and gallium because of low melting point. Now, what are the chemical properties? Metal reacts with air. Yes, 100% reacts with air. Copper reacts with oxygen to produce copper oxide, which is black in color. Protective corroding metal, remember the name of metals that protect other metals or themselves from being corroded if they develop a layer of oxide on their surface. Magnesium protected by making magnesium oxide layer, aluminum by aluminum oxide, zinc by zinc oxide and plumbus by plumbus oxide. Here you can see copper does not burn but is coated with black copper oxide. When you try to burn copper, it will cover it with the black copper oxide without burning and never burns. The oxides that are going to react with base as well as acid are called amphoteric oxides. Aluminium, zinc, lead can react with both acids and bases as mentioned in the equation. When they react with hydrochloric acid, aluminum chloride is produced. When they react with powerful base, that is NaOH, sodium aluminate is formed. Now, reaction with water. Metal oxides on dissolution of water gives base. Some bases are soluble in water called alkali, NaOH, KOH. Calcium starts floating Q. Why calcium starts floating? Because bubbles of hydrogen gas stick to the surface of metal and they lift the metal up to the surface. Magnesium does not react with cold water but react with hot water to produce hydrogen gas. Magnesium, remember magnesium does not react with cold water but react with hot water. Aluminium, zinc and iron reacts with steam. Remember aluminium, zinc and iron reacts with steam to produce respective oxides. They are not going to react with cold water or hot water. They only react with steam. Again, lead, copper, silver, gold and platinum do not react with water. Lead, copper, silver, gold and platinum do not react with water. Metals have placed above hydrogen in activity series easily reacts with dilute acid HCl and H2SO4 and give hydrogen gas, but no reaction with dilute nitric acid, as nitric acid is oxidizing agent and produces H2O, NO2 and NO3. Similarly, sulfuric acid will produce sulfate, sulfur dioxide and sulfur trioxide. Magnesium and manganese, remember one question must be here. Magnesium and manganese react with dilute nitric acid to produce hydrogen gas. The question can be asked, which metal reacts with dilute nitric acid? The answer will be magnesium and manganese in your case. Similarly, copper, mercury does not react with dilute acid. Remember, question can be asked regarding copper and mercury, whether they react with dilute acids or not. Formation of hydrogen bubbles is vigorosity of the reactions. How vigorous the reaction will be depend on formation of hydrogen bubbles. More hydrogen bubbles, vigorous the reaction. Now move to the next part, that is called anodizing. That means the process of forming a thick oxide layer of aluminum that protect it from corroding. Corrosion से बचाने वाला aluminum oxide, they are going to be made by aluminum article which is made anode electrolyzed with sulfuric acid. When it is electrolyzed with sulfuric acid, you can get the aluminum article as covered up. Cover the article with aluminum oxides. Aquaresia. The question can be asked, what is royal water? You can easily answer. Conc nitric acid and conc hydrochloric acid in the ratio of 1:3. When they are combined together, that means fuming acids. and it is freshly prepared, then it will behave as aqua regia, and as it can dissolve the noble metals like gold and platinum, so it is also known as royal water. Now I have prepared this chart, reactivity of metals, how different metals behaves or reacts in the presence of different conditions. So reaction with oxygen, potassium and sodium, they are highly reactive, easily reacts with oxygen. Calcium, magnesium, aluminium, zinc, iron, they are going to react with oxygen to form respective oxides, but in less vigorous manner. Lead, copper, silver don't burn, but only form a surface layer of oxides, lead, copper and mercury. Similarly, silver, platinum and gold don't burn, oxidize even at the surface. Second case, reaction with cold water, potassium to magnesium displace hydrogen from cold water. From aluminium to gold, do not displace hydrogen from cold water. That means they are not going to react with cold water. Reaction with steam, potassium to iron displace hydrogen with steam without decreasing reactivity. Potassium to iron. After that, from lead to gold, do not displace hydrogen from steam. Reaction with dilute strong acids, potassium to lead displace, copper to gold, no displacement. Reaction with chlorine, all metals react with chlorine on heating to form their respective chlorides, but with decreasing reactivity from top to bottom. सारे के सारे react करते हैं. Starting from potassium chloride to aurum chloride. Now let us go to the next part, that is chemical properties. You all know carbon reacts with oxygen to produce carbon dioxide. Dissolution in water gives us carbonic acid. Similarly, sodium on reacting with hydrogen to produce sodium hydride. Here one question will be there. Which metal reacts with hydrogen to produce sodium hydride? You can go or rely on this fact and you can write the answer as sodium. This is one of the important part of this chapter. Now go to the electrovalent compounds. Actually, electrovalent compounds are produced when electrons are transferred from metal part to non-metal part. Here you can see magnesium, which has 2 valence electrons in its outermost orbit. ठीक है, मैग्नीशियम का 2 इलेक्ट्रॉन बाहर है 282 में. क्लोरीन 287 यानी कि 1 इलेक्ट्रॉन ले सकता है, इट इज नेगेटिव रेडिकल टू कंप्लीट इट्स ऑक्टेट. तो व्हाट हैपेंस, वन मैग्नीशियम इज गोइंग टू गिव इट्स इलेक्ट्रॉन टू 2 क्लोरीन एटम्स. 2 क्लोरीन एटम को वो एक इलेक्ट्रॉन दे रहा है. इन दिस वे दे आर गोइंग टू फॉर्म मैग्नीशियम क्लोराइड MgCl2, which is actually an electrovalent or ionic compound. Now, formation of electrovalent or ionic compound with electron dot structure, the question can be asked. You have to go with this direction, or you can say you have to go back to the concept, how they are going to react. Now, move to the next part, that is called metallurgy. Metallurgy is connected with occurrence of metal. How metal occurs in our earth crust? In different forms. First, oxide ores, which are highly reactive. Second, carbonate ores, middle order. Sulfide ores, middle order. Sulfide ores, low reactivity. So actually, how they are going to extract it from the metal? Oxide ores by electrolytic reduction. Carbonate by calcination, sulfide by roasting, and after calcination and roasting you will get the oxides, which can be reduced using carbon. But metals of low reactivity, which are present as sulfide ores, only converted into respective oxides by roasting, and these oxides on heating easily release the metals. Here I have mentioned some important ores that you must have to remember. For iron it is hematite, Fe2O3, aluminium bauxite, Al2O3.2H2O. Similarly, zinc blend ZnS, calamine ZnCO3. These few ores I have mentioned that may be asked in your question, which metal can be extracted from these ores: hematite, bauxite, zinc blende or calamine. These four you can go for. केमिकल रिएक्शंस रिगार्डिंग एक्सट्रैक्टिंग मेटल्स, कौन कौन सा रिएक्शन इन्वॉल्व होगा? अगर ऑक्साइड ओर है तो ऑक्साइड इफ लो ऑर्डर का है तो सीधे गर्म कर दो, अगर सल्फाइड ओर है तो ऑक्सीजन के प्रेजेंस में हीट कर दो, मतलब रोस्टिंग। कार्बोनेट ओर है तो सीधे गर्म कर दो, यू विल गेट ऑक्साइड विथ कार्बन डाइऑक्साइड, और उस ऑक्साइड को हटाने के लिए फिर से कार्बन का यूज कर लो टू रिड्यूस, जिंक विल बी रिलीज्ड ऑटोमेटिकली, that is called calcination. Heating in the presence of oxygen, roasting; heating in the absence of oxygen, calcination. और ऑक्साइड्स वाले का इलेक्ट्रोलाइटिक रिडक्शन. Here we have taken few examples how electrolytic refining of copper is done. Impure copper is used to make anode, pure copper can be used to make cathode, and take the copper sulfate solution as electrolyte, pass electricity, copper will move from anode to cathode, giving pure copper at cathode and impurities near anode called anode mud. Similarly, the same thermit reaction is there, which is used for welding purpose, melting purpose, or repairing of the cracks and the breaches. Now corrosion, which we have learnt, applying oil or grease to protect it from corrosion, the slow attack of atmospheric passage which is the cause of corrosion, and after this the formation of alloy. Alloy का formation homogeneous mixture है, two metals, metals and non-metals, they will go to produce the steel. Now go for the important corrosion reactions. All the reactions are very important here. Here tarnishing of silver, black, copper, green, iron, reddish brown. Go through these corrosion reactions carefully and write in your copy to remember, because any one of these can be asked in your board exam. So now we will move to the chapter 4, which is carbon and its compound. In carbon and its compound, what we have to study about carbon, about the covalent bond it forms, and what is the difference between electrovalent and covalent bond, the allotropy, versatile nature of carbon, hydrocarbons, homologous series, functional groups, nomenclature, structural diagram, chemical properties of carbon compound, some important carbon compounds, and soap and detergent. Because we have to go with carbon, which is the most important chapter of chemistry in your board exam. Now let us go for carbon. In carbon, the atomic number is 6, electronic configuration 2,4, which shows 4 electrons in the outermost orbit. Now the question will arise, why it can't lose or gain 4 electrons or gain electrons to complete octet like electrovalent compounds? The answer will be there. If it is going to gain 4 electrons, the 6 protons that are present in the nucleus are unable to hold it, because there will be 10 electrons in the orbit and only 6 protons to hold them, which is impossible. Another case, if they are going to lose 4 electrons, it is very difficult and requires a large amount of energy to remove it. So it is impossible for carbon to lose or gain electrons. After that, how it overcomes? By sharing the valence electrons with other carbon atoms or some other covalent compound formation. किसी भी एटम के साथ वो अपने इलेक्ट्रॉन्स को शेयर करके अपना ऑक्टेट पूरा कर सकता है. That is carbon. Now the question arises of covalent bond. The bond formed by sharing of electrons is called covalent. Simple language. F2, iron, fluorine, 7 electrons in the outermost orbit share 1 electron with another fluorine to make F2. Chlorine same, hydrogen same, HCl hydrogen shares with chlorine. Water, oxygen shares with 2 hydrogen atoms. Methane, carbon shares with 4 hydrogen atoms. Ammonia shares with 3 hydrogen atoms, as its electronic configuration says 2, 5. 3 electrons required, which it takes from hydrogen, in place it gives 3 hydrogen. After that, double covalent bond like oxygen and carbon dioxide. In oxygen, 2 electrons are required to complete their octet. So oxygen shares with another oxygen atom these 2 electrons. 2 देता है 2 लेता है, हो गया डबल बॉन्ड. अगर वही 3 देता है, as the case of nitrogen is there, तो 3 देना 3 लेना, ट्रिपल बॉन्ड. This is the structure that you can take it from your books also, and question may be asked regarding formation of covalent compounds of oxygen, nitrogen, show. Now what is allotropy? Property by which an element can exist in more than one form that are physically different but chemically similar. सिंपल लैंग्वेज में समझिए, सिर्फ और सिर्फ वही नॉन मेटल या मेटल होना चाहिए इन द स्ट्रक्चर. नो अदर मेटल और नॉन मेटल और एलिमेंट इज इन्वॉल्व. दैट पर्टिकुलर टाइप ऑफ स्ट्रक्चर इज कॉल्ड एलोट्रॉप. जैसे कार्बन का क्रिस्टलाइन एलोट्रॉप, क्रिस्टल फॉर्म में 3, डायमंड, ग्रेफाइट एंड फुलेरिन. डायमंड में 4 एटम्स होते हैं, टेट्राहेड्रल स्ट्रक्चर. 1 carbon is central, 4 carbons are at the 4 corners. 3-dimensional tetrahedral structure. Similarly, graphite, hexagonal structure with van der Waals forces, which provides softness to graphite so that it can slip over one another. The other one is fullerene, which contains a football-like structure with 20 hexagons and 12 pentagons. This is actually the allotropes of carbon. 3 diamond, graphite, fullerene. Structure may be asked. Go to the book and try to draw the diagram. Now the question arises, what is versatile nature of carbon? Versatile होता क्या है? Universal presence, सब जगह पाया जाने वाला, versatile nature. क्यों? Catenation and tetravalency. क्या कैटेनेशन? लिंकिंग प्रॉपर्टी. मतलब एक कार्बन दूसरे कार्बन से लिंक कर सकता है इन द फॉर्म ऑफ ए लॉन्ग चेन, ब्रांचेज, साइकिल्स, रिंग. दिस प्रॉपर्टी ऑफ कार्बन इज कॉल्ड कैटेनेशन. टेट्रावैलेंसी, कार्बन के पास 4 वैलेंस इलेक्ट्रॉन की जगह. दैट मीन्स इट कैन शेयर विथ ऑल साइड with 4 carbon atoms, with 4 hydrogen atoms, or 4 different atoms of different element. This property of carbon to share electrons with 4 same or different atoms of different element is called tetravalency. Now move to the another topic, hydrocarbons. The compound of carbon and hydrogen is called hydrocarbons. 3 types: saturated single bond, unsaturated double or triple bond, aromatic benzene ring. That means if the benzene ring is present, the hydrocarbon is called aromatic hydrocarbon. And other saturated and unsaturated both are called aliphatic hydrocarbons. Saturated alkanes single bond, general formula CnH2n plus 2, alkene CnH2n double bond, alkyne CnH2n minus 2 triple bond. Now if any series of compounds follow the same general formula with a common difference of CH2 or 14 atomic mass unit, the series is called homologous series. सिंपल लैंग्वेज, वो सीरीज जिसमें एक ही जनरल फार्मूला को सब फॉलो करें. दूसरी तरफ दे हैव सेम फंक्शनल ग्रुप, सेम टाइप ऑफ बॉन्ड, एंड द डिफरेंस बिटवीन 2 consecutive member is CH2 or 14 atomic mass unit. Nomenclature, नाम लिखने के लिए आ सकता है. How to get the nomenclature? Just count the number of carbon atoms, use the prefix whatever is there. 1 for meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, 10 dec. उसके पीछे लगा दीजिए सफिक्स. अल्केन के लिए ANE, तो मिथ से मिथेन, इथ से इथेन. अल्कीन के लिए ENE, इथीन, प्रोपीन, ब्यूटीन. आइन के लिए YNE, इथाइन, प्रोपाइन, butane, and so on. Similarly, other functional group shows other characteristic. Here I have given some. Chloropropane, 3 carbon propane, single bond is there. Similarly, bromine is present, the bromopropane. If OH is present, propanol. If CHO is present, propanol. If carbon and oxygen present at the central atom with 2 carbon on 2 sides, it is called known ketone group, propanone. Similarly, carboxylic acid, COOH, propanoic acid. Alkenes with double bond present there between 2 carbon atoms. Alkynes, 3 triple bond present between 2 carbon atoms. Next, chemical properties of carbon compounds. The first property is combustion. It is different from oxidation. Combustion produces light and flame. That means heat and light. When you burn carbon in the presence of oxygen, it will produce carbon dioxide with heat and light. Similarly, methane burns CO2, H2O, heat and light. So whatever saturated carbon compounds are there, if they are going to burn, they will produce blue flame with heat and light. And this is saturated hydrocarbons. But if we are taking alkenes and alkynes, that is unsaturated hydrocarbons, they will produce yellow flame with incomplete burning and black smoke. Difference can be asked regarding combustion or chemical properties. Next will be the oxidation. For oxidation requires some oxygen supplying agents. Here potassium permanganate, which work in alkaline medium, or acidified potassium dichromate, which is acting in acidic medium. What happens in oxidation? Alcohol, any alcohol which follow the formula CnH2n plus 1 OH. Here CH3 CH2OH or C2H5OH. When heated in the presence of acidified potassium dichromate or in the presence of alkaline potassium permanganate, if they are heated, they will convert into respective acid. 2 कार्बन्स आर देयर, मतलब 2 कार्बन अल्कोहल के हैं तो 2 कार्बन वाला एसिड बनेगा, दैट इज एसिटिक एसिड, also known as ethanoic acid. So remember this oxidation, alcohol converts into acid. Addition reaction. Alkenes and alkynes undergo addition reaction in the presence of a special condition. That means hydrogen is added in the presence of nickel or palladium as catalyst. It is called addition reaction. And here alkene will convert into alkanes. Alkyne will convert into alkene into alkanes. Similarly, vegetable oil, nickel as a catalyst, hydrogen. At 200 centigrade, it is converted into ghee. Now, substitution reaction, which is the property of saturated hydrocarbons. Substitution reaction is the property of saturated hydrocarbon. Here, methane, which is a saturated hydrocarbon, chlorine is going to react with methane in the presence of sunlight to produce methyl chloride with HCl gas. Again, methyl chloride continue with chlorine at sunlight to produce dichloromethane. On the other hand, dichloromethane again react with chlorine in sunlight to produce chloroform or trichloromethane. Chloroform, you know, used as anesthesia. Similarly, carbon trichloromethane or chloroform reacts with chlorine in the presence of sunlight to produce carbon tetrachloride, which is universal solvent for organic compounds. After this, we have to go with some important carbon compounds. That is our ethanol. How to prepare it? You all know ethanol is prepared by fermentation of sugar solutions. It is a colorless liquid with pleasant smell and burning taste. It is highly soluble in water. In some cases, we have to go with denatured alcohol, which is used as fuel. So denatured alcohol means adding dyes, color, or even methanol in it so that it can't be used for drinking purpose. This is the denatured alcohol. Remember, the question may be asked, what is denatured alcohol? You have to answer it. Addition of dyes, color, and some poisonous substance in ethanol make it denatured alcohol. What are the reactions of ethanol? Ethanol reacts with sodium to produce sodium ethoxide C2H5ONA with release of hydrogen gas. Ethanol reacts with conch sulfuric acid at 443 Kelvin to produce ethene. Ethanol to ethene, remember, ethanol to ethene in the presence of conch sulfuric acid, which is acting as dehydrating agent. That means removing water from alcohol. It is used for making alcoholic drinks, solvent, medicines, antifreeze, automobile radiators, etc. Now move to the next one, which we have to study is ethanoic acid. Acetic acid is also known. Ethanoic acid is a colorless, pungent smelling sour taste. It is also known as vinegar when the solution contains 5 to 8% in water. Reactions of ethanoic acid, two reactions are there, esterification and saponification. That means when alcohol and acids are going to react, they undergo reversible reactions. You can see here CH3 CH2OH reacting with CH3 COOH, CH3 COOH, CH3 COO will remain there and it will take CH2 CH3 from the left side. This will undergo like CH3 COO CH2 CH3. Now saponification, when the ester reacts with sodium hydroxide solution and they will make sodium acetate with ethanol. Just formation of soap, also known as saponification. But this saponification is studied on the basis of just acetic acid and ethanol. But when the number of carbon atoms will increase, as in the case of stearic acid or palmitic acid, which contains a large number of carbon atoms in different oil form, if they are going to react with sodium hydroxide, they will make our carboxylic soaps. So we will learn in the next slide. Here ethanoic acid reacts with sodium hydroxide to make sodium ethanoate or sodium acetate. Similarly, if it is going to react with sodium carbonate, sodium hydrogen carbonate, the same reaction will be there, but the release of carbon dioxide will add up. Now get this soap and detergent. Soaps are chains of sodium or potassium salt of carboxylic acid. किसका? सोडियम का और पोटेशियम का. C17H35COONA, C15H31COONA. These are two different types of soap which contains sodium along with carboxylic chain, as shown in the figure. As shown in the figure, you can see here. Here is your sodium which is attached with carboxylic chain, and this carboxylic chain contains a large number of carbon atoms which it has obtained from carboxylic acid, because here is the formula C17H35COOH. From here the sodium is going to release its hydroxide ion and give it and attach itself with the carboxylic group. Now in this condition the sodium end is called hydrophilic and the carboxylic end is called as hydrophobic. And this is the structure of soap which helps in the formation of micelle. I can see the cleansing action of soap. What happens in it? The sodium that forms the outer hemisphere or outer surface of the bubble of a micelle, and the inner surface is connected with the carboxylic chains. You all know oil is going to collect at one point. Whenever they are stirred in water, they will automatically connect themselves and form a small structure. This particular small structure is present at the center, which is used to clean the clothes, as our clothes contain oil, grease and different types of salt connected with it. But this particular thing, if it is put down inside the micelle formed by soap, the organic part will go to the center with all the sodium content around the surface. And as sodium has adhesion towards water particles. It will take away all the water along with the dirt or dust, just it is going to clean the cloth. Now again, what is detergent? It can work in hard water also. So here you have to remember, detergents are long chain of sodium salt of sulfonic acid, and that was soap, which is of carboxylic acid. Soap do not wash well with hard water because it forms insoluble precipitate in calcium and magnesium salts in hard water. But in detergents, such condition was not there because it does not form insoluble precipitate of calcium and magnesium salt in hard water. Now the last part of it is difference between soap and detergent. You have to remember it. Any 2 points you have to write in your answer sheet. Soaps are sodium salts of fatty acids, detergents are sodium salts of sulfonic acid. Soap clean well in soft water but do not clean well in hard water. Detergents clean well in soft and hard water. Soaps are biodegradable. That means they can be removed or decomposed with the help of organic materials biologically without polluting the environment. But detergents are non-biodegradable and causes pollution.